So the live begin within 4 minutes. So the live begin within 4 minutes. Right, let's wait for 4 more minutes. Let's start the live session at 6:40 sharply. Let's start the live at 6:40 p.m. sharply. Am I audible? Can anybody respond in the chat box? Can anybody respond in the chat box? Am I audible? Yes, very nice. So we'll wait for 3 more minutes. We'll wait for 3 more minutes. We'll wait for 3 more minutes. So let's discuss matrices topic today. In this live session, I am going to deliver each and every synopsis content. This could be helpful for you a lot. So still students are joining. I'll be wait 2 more minutes. Sharply at 6:40 I will start the session. Meanwhile, you can forward this live class link to all your classmates. మీ వాట్సాప్ గ్రూప్స్ ఉంటాయి కదా, మీ ఫ్రెండ్స్ గ్రూప్స్, వాట్సాప్ గ్రూప్స్లో ఈ క్లాస్ లింక్ ఫార్వర్డ్ చేయండి. అండ్ ఈ సెషన్ అనేది చాలా బాగా యూస్ఫుల్ ఉంటుంది మీకు. సో ఏ బ్రాంచెస్ నుంచి ఉన్నారు ఒకసారి కామెంట్స్లో రాయండి. బ్రాంచెస్ రాయండి ఒకసారి. వాట్ ఆర్ ద బ్రాంచెస్ ప్రెజెంట్ హియర్? రైట్, ఏ బ్రాంచెస్లో ఉన్నారు రాయండి. వాట్ ఆర్ ద బ్రాంచెస్ ప్రెజెంట్ హియర్? రైట్ డౌన్ ఇన్ ద కామెంట్ బాక్స్. ఏ బ్రాంచెస్ నుంచి ఉన్నారు? Very nice. ECE, EEE, mechanical, civil, mining, ECE, CSE. Okay, all the branch students are present here. రైట్, ఏ కాలేజెస్ నుంచి ఉన్నారు? కాలేజెస్ నేమ్స్ రాయండి, ప్లేసెస్ నేమ్స్ రాయండి. మీ కాలేజెస్ లైక్ జీపీటీ కడప, జీపీటీ విజయవాడ, జీపీటీ కొత్తగూడెం, జీపీటీ వరంగల్, అట్లా ఏ కాలేజెస్ నుంచి ఉన్నారు? రైట్ ఆన్ యువర్ కాలేజ్ నేమ్స్. మీన్ వైల్ స్టూడెంట్స్ ఆర్ జాయినింగ్. ఏ కాలేజెస్ నుంచి ఉన్నారు? write down here your college name. కాలేజెస్ నేమ్స్ రాయండి, ఇంకా జాయిన్ అవుతున్నారు. కాలేజ్ నేమ్ బ్రాంచెస్ రాస్తున్నారు. వెరీ నైస్. జీపీడబ్ల్యూ కడప, ఐతం టెక్కలి. కాలేజ్ నేమ్ రాయండి, కాలేజ్ నేమ్స్. నల్గొండ, మదిర, అమలాపురం. వెరీ నైస్. పల్లవి ఇంజనీరింగ్ కాలేజ్ నాగోల్, వరంగల్, కొత్తగూడెం, నర్సీపట్నం, అమలాపురం, ప్రొద్దుటూరు, మంచిర్యాల్, శ్రీ విద్యానికేతన్ తిరుపతి, సూర్యాపేట, మదనపల్లి, శ్రీ చైతన్య కాలేజ్ హైదరాబాద్, సికింద్రాబాద్. వెరీ నైస్, వెరీ నైస్. చాలా ప్లేసెస్ నుంచి స్టూడెంట్స్ ఉన్నారు. గజ్వేల్, నంద్యాల్. యా, వెరీ నైస్, వెరీ నైస్. ఓకే, సో నౌ లెట్స్ స్టార్ట్ ద సెషన్ స్టార్ట్ చేద్దాం. ఇన్ టుడేస్ class I am going to discuss about the concept matrices. So first, before I am going to begin, what is the definition of matrix? So matrix is nothing but it is a rectangular arrangement of real or complex numbers. So it is a rectangular arrangement of real or complex number. So in school days we started the application of this matrix. స్కూల్లో మనం ప్రేయర్కి నించున్నప్పుడు నెంబర్ ఆఫ్ రోస్, నెంబర్ ఆఫ్ కాలమ్స్ కింద నిలబడ్డాం. సో అక్కడి నుంచి మనం ఈ మ్యాట్రిసెస్ అప్లికేషన్స్ని చూస్తూ వచ్చాము. దీన్ని క్యాపిటల్ లెటర్స్లో డినోట్ చేస్తాం. సో ఫర్ ఎగ్జాంపుల్, క్యాపిటల్ ఏ ఈజ్ ఈక్వల్ టు the format of matrix. I am writing the format of matrix A11, A12, A13. So let us write up to nth, A13, so on A1n. So second row A21, second row first element, second row second element, so on A23, so on A2n. ఇట్లా థర్డ్ రో రాస్తే A31, A32, A33, so on A3n. So up to AM1, AM2, AM3, so on up to AMN. Okay, a matrix having m rows and n columns whose order is m cross n. Here m indicates number of rows, m rows, and n columns. So order is nothing but number of rows into number of columns. Order is nothing but number of rows into number of columns, which can be written as m cross n, which is nothing but order of the matrix. Order of the matrix. So the definition of order, again I am saying, number of rows into number of columns. Okay, and in the mathematical form, how to denote this matrix? So here you can see Aij, ith row jth column. So A is equal to Aij, whose order is what? Whose order is m cross n. Whose order is m cross n, where I lies between 1 to m, whereas j lies between 1 to n. Okay, in the mathematical way we can able to denote the matrix in this format. right? Now let us discuss what are the types of matrices. So this is the mathematical notation of a matrix, and also definition I given, and also I given the definition of order. Now let us discuss what are the various types of matrices. In the entire today's session, let us study about what are the types of matrices. So this is very important parameter. Once if you learn all these types of matrices, then you can have some command on matrices topic. So the first matrix that we have is square matrix. The first matrix, let us learn square matrix. So what is meant by square matrix? A matrix in which the number of rows is equal to number of columns. So simply writing rows equal to columns, number of rows equal to number of columns. That matrix is nothing but square matrix. Number of rows equal to number of columns. For example, if I write a matrix like 1, 2, 3, 4, how many number of rows are here? There are 2 number of rows. And how many number of columns are here? There are 2 number of columns. As you can see, the number of rows is 2, which is equal to number of columns, which is 2. That means order of matrix is nothing but 2 cross 2. Hence the given matrix is said to be square matrix. For example, if I write like 1, 2, 3, 4, 5, 6, 7, 8, 9. You can observe here number of rows. Here number of rows are 3 and number of columns are 3. As you can see, the number of rows is equal to number of columns. 3 cross 3. Both are same. Hence the given matrix is said to be square matrix. In this, you can see here 1, 5, 9. These are called principal diagonal elements. PDE. Diagonal elements. Simply diagonal elements are principal diagonal elements. Right? And second type of matrix, let's discuss, which is rectangular matrix. So what is this rectangular matrix? Here a matrix is said to be rectangular in which the number of rows is not equal to number of columns, quite opposite to the previous one. So if the number of rows is not equal to number of columns, then the matrix is said to be rectangular matrix. So simply I am writing rows is not equal to columns. Rows not equal to columns. That matrix is said to be rectangular matrix. If I write one example here, if I write one example 1, 2, you can see here the number of rows are 2 and the number of column is 1. So the order of matrix is 2 cross 1. Okay. Next one, if I write one more example 1, 2, 3, 4, 5, 6. So the number of rows here it is 2 and the number of columns here it is 3. So the order of matrix is 2 cross 3. Order of matrix is 2 cross 3. As you can see, the number of rows are not equal to number of columns. Hence the matrix is known as rectangular matrix. So this is the second type of matrix. So let's go with the third type of matrix. Let me erase this. Let us discuss the class so that an average student can also able to understand this class. Right. So let's discuss about the third type of matrix, which is row matrix. So the name itself says a matrix which is having only one row is nothing but row matrix. So simply writing only one row. That matrix is nothing but row matrix. For example, if I write 1, 2, 3, this matrix is having only one row. Hence it is called row matrix. So one row, then how many columns? Whatever it may be. Here there are 3 columns. If I ask what is the order of the matrix? The order of the matrix is nothing but 1 cross 3. So this is nothing but row matrix. And next one, we'll discuss the fourth matrix, which is column matrix. So what is meant by column matrix? You can see here a matrix which is having only one column is nothing but column matrix. So simply I am writing only one column is nothing but column matrix. If I write one example, 1, 2, 3. So how many rows are here? Here there are 3 rows. And how many columns are here? There is only one column. So what is the order of the matrix? 3 cross 1 is the order of the matrix. So which is the fourth matrix. Now let us discuss the next type of matrix, which is very important, diagonal matrix. Which one is diagonal matrix? So let's discuss the next type of matrix, which is very important. Diagonal matrix. So what is meant by diagonal matrix? A square matrix in which all its elements are zeros except principal diagonal elements. You can see here I am writing the format. Let us take a square matrix. Except principal diagonal elements, all the elements are zeros. So except PDE. So let us write PDE as 1, 2, 3. Remaining all the elements are zeros. Remaining all the elements are zeros. Except PDE. Principal diagonal element, if you can see here, it is non-zero. Such matrix is nothing but which matrix? Diagonal matrix. So let's have one format for this. A is equal to A11 0 0 0 A22 0 0 0 A33. So first row first element, A11 means. A22 means second row second element. A33 means third row third element. Except principal diagonal elements, you can see here, except principal diagonal elements, remaining all the elements are what? Zeros. Hence this matrix is called as diagonal matrix. Hence this matrix is called as diagonal matrix. Whenever a diagonal matrix is given, then there are some techniques to compute det A. How to compute det A? And there is some technique to compute A inverse. And there is some technique to compute A power m. There is some shortcut method. Whenever a diagonal matrix is given, then det A is nothing but A11 into A22 into A33. What is this? Product of principal diagonal elements. Product of principal diagonal elements. And A inverse is nothing but 1 by A11, 0, 0, 0, 1 by A22, 0, 0, 0, 1 by A33. Just the reciprocal of principal diagonal elements. This is A inverse shortcut. If I ask you to what is the A power m, what is the value of A power m? So here I am writing. It is very simple. Just making its powers. A11 power m 0, 0, 0. A22 power m 0, 0, 0. A33 power m. A33 power m. For example, let's have one example here. The question given like this. Now, I want to compute what is det A and also what is A inverse, and also I want to compute what is A cube. These three things I want to know. How to get these three things? First one, det A. As I said clearly, det A is nothing but product of principal diagonal elements. Alright? So 1 into 2 into 3, which is nothing but 6. Second, A inverse. What is A inverse? A inverse is nothing but just write its reciprocals. So 1 by 1, which is 1, 0, 0, 0, 1 by 2, 0, 0, 0, 1 by 3. Next, A cube. Just write its powers. 1 cube, which is 1, 0, 0, 0. 2 cube, which is 8, 0, 0, 0. 3 cube, which is 27. So in this way, we can able to answer the given questions in smarter way. Understood? So we will go for next thing. Please note down this. The fifth kind of matrix that I discussed as diagonal matrix. Kindly note down this. Yeah, I will explain all your doubts. Somebody asking for trigonometry in the chat box. Everything I am going to explain. Please forward this link, class live link, to your friends so that Each and every topic I am going to discuss in detail. An average student can also able to understand these all concepts. Once if you understand all these concepts, you can able to solve any kind of question. So let us begin from basics. So as today's first class as matrices, I begin off saying about all the types of matrices and what are the topics present in these matrices. So kindly share the class link to all of your friends. Yeah. Now let's go to next type of matrix. I hope you copied the fifth one, diagonal matrix. So the next type of matrix, which is sixth matrix, sixth type, I am writing as a order, which is nothing but scalar matrix. So what is scalar matrix? A square matrix in which all the diagonal elements are equal and all the other elements are zeros. So here you can see, clearly observe the difference. Here all the diagonal elements, whatever I will write, they must be same. Some scalar constant k I written. Remaining all the elements are what? Zeros. Such matrix is known as scalar matrix. Okay. For example, examples of scalar matrix I will write 5 0 0 5. This is a scalar matrix of order 2 cross 2. If I write a scalar matrix of order 3 cross 3, 2 0 0 0 2 0, all the PDs are equal. Remaining elements should be zeros. Such matrix is nothing but scalar matrix. Okay, such matrix is nothing but scalar matrix. So this is the sixth type of matrix. Now let us discuss the next type of matrix, which is seventh one. Let me erase this. Seventh type of matrix, which we have unit matrix. This unit matrix is also called identity matrix. Identity matrix. It is generally denoted with I. If a matrix of order n, which is In. So a square matrix in which all its diagonal elements are 1 and all other elements are equal to 0. That is nothing but identity matrix or unit matrix. So all the diagonal elements are 1. Remaining all the elements are zeros. So this is identity matrix of order 3 cross 3. Okay, such matrix is nothing but unit matrix or identity matrix. So next, let us discuss the next type of matrix, which is eighth matrix, eighth type. Let me discuss each and every point very clearly so that you can able to solve any kind of question. Today I am going to tell all the types of matrices in this class. Right. Next, the serial number 8th one, which is null matrix, which is nothing but, which is also called as zero matrix. So generally it is denoted with O of order m cross n. So null matrix is nothing but a matrix whose all elements are zeros. So this is null matrix of order 2 cross 2. A matrix whose all elements are null set or zeros. Such matrix is nothing but null matrix or zero matrix. Now let us discuss next important two types of matrices, ninth and 10th. Ninth matrix and 10th matrix I am going to discuss here, which are triangular matrices, which is first one is upper triangular matrix. First one is upper triangular matrix, and second one is we have lower triangular matrix. So what is upper triangular matrix? So first let me write a matrix So let me write the principal diagonal elements, whatever the values. 1, 2, 3 are written. Upper triangular matrix means, upper means above. Just think in a reverse way. That is below the principal diagonal elements. Below the principal diagonal elements are zeros. Below the principal diagonal elements are zeros. Above, whatever it may be, above, like 6, 7, 9, whatever the values. So this is the principal diagonal elements. As you know, 1, 2, 3 here are principal diagonal elements. Below the principal diagonal elements, all the values are zeros. Such matrix is known as which matrix? Upper triangular matrix. Okay. So I want to represent this in this one in also mathematical form. If I ask what is this element, this is 2, 1, right? 2, 1. Second row, first element. This one is third row, first element, 3, 1. A 3, 1 simply. This one is 3, 2. A 3, 2. Okay. Then you can observe here which values are zeros. This is I, this is J. So A is equal to Aij, whose value is 0. For all, I is greater or J is greater? I is greater here. Again Ij, I is greater. Ij, I is greater. For all, I is greater than J. Such matrix is called as upper triangular matrix. This is the mathematical notation. Okay. And coming to the next one, lower triangular matrix. So lower triangular matrix, just let me write here. A is equal to, let me write the principal diagonal elements. Let it be something 1, 2, 3. Lower means below. So just I ask you to think opposite way. Means above. Above all the values are what? Zeros. Above what? Above principal diagonal elements. Above principal diagonal elements, all the values are zeros. Such matrix is called as lower triangular matrix. So below of this, whatever the values, let it be 6, -9, 7, something, whatever the values. If I ask you to represent in mathematical way, So first let us mark the positions. What are the positions? This is 1 2, first row, second element. This is 1 3, first row, third element. And this one is 2 3, second row, third element. Okay, second row, third element. If I ask you to represent in mathematical way, so how shall we write this? A is equal to Aij, okay, whose value is 0 for all. You can check here, I is greater or j is greater. I value is 2, j value is 3. I value is 1, j value is 3. So for all I less than j, for all I less than j, okay, for all I less than j, this is the thing going to happen. Alright, so note down these two. This is about lower triangular and upper triangular matrices. Please note down these two. So 9th and 10th types are over. Now let us discuss the next type. Next type of matrix. So let's discuss the next types of matrix. 11th type. Let me erase all this. So far we discussed 10 types of matrices. Now let us discuss the next type of matrix, which is 11th type of matrix, which is symmetric matrix. This is important one. So what is meant by symmetric matrix? And parallelly, let's discuss skew symmetric matrix. So what is meant by skew symmetric matrix? These two things we will discuss now. So what is meant by symmetric matrix? A matrix A is said to be symmetric. A square matrix or a matrix A is said to be symmetric if transpose of the matrix is nothing but the given matrix. Transpose means what? Interchanging the rows and columns. Okay, transpose of a matrix is equal to given matrix. That matrix is said to be symmetric matrix. So let's have one example for symmetric matrix. First very important point you need to note here is, while writing the symmetric matrix, the principal diagonal elements must be always real numbers. The principal diagonal elements always real numbers. Remember that point. The PDE must be real numbers. So let's have one example. For example, if I write A is equal to, so I said that PDE are real numbers. So 1, 2, 3, these are real numbers, or minus 3, whatever. I written 3 here. If I write 6 here, what is the position? The position is first row, second element. 1, 2 is the position. What is its replica? Its replica is 2, 1. 2 1 here the same 6 should be repeated. Okay, and if I write 9 here, what is the position? 1 3, its replica, just reverse it. 1 3 3 1 3 1 position, write the same 9. Okay, write the same 9. If I write 7 here, what is the position? What is the position? 2 3, reverse it. 3 2, write the same 7 here. Okay, now this is the given matrix. He don't ask you to write an example of symmetric matrix. He will give the given matrix is dash. Option A symmetric, option B skew symmetric. Likewise 4 options will come. Some other options singular, non-singular, likewise. So this is the given matrix. I told that transpose of a matrix equal to given matrix. That matrix is said to be symmetric matrix. Just first step is to do its transpose. Transpose is nothing but just interchanging the rows and columns. So just I am erasing this skew symmetric as of now. Let's discuss this. So interchange the rows and columns. So this is the first column. I am writing this column as row, which is 1 6 9. This is row. Again the second column as second row, 6 2 7, and the third column as third row, 9 7 3. Okay, I done transpose of a matrix. Now you can check both of these. Both are same. Hence the given matrix is said to be symmetric matrix. Got it? If a matrix A transpose is equal to A, the matrix is known as symmetric matrix. Remember that. Here there are some properties. If you take a zero matrix and diagonal matrix, zero matrix, diagonal matrix, there is one more matrix like identity or unit matrix. The zero matrix, any diagonal matrix, and unit matrix, these are always symmetric matrix. If you want, you can do transpose and check it, you will get symmetry. These are symmetric in nature. Okay, first property. And second property, if A is symmetric, then A plus A transpose, A into A transpose, A transpose into A. These matrices are always also symmetric matrices. Okay, these matrices are also symmetric matrices. This is the second property. And the third property, let me write. If A is symmetric, then A power n is also symmetric. A power n is also symmetric, where n is real numbers 1, 2, 3, so on. If A matrix is symmetric, A power n is also symmetric. These properties may come as a theory bits in the examination. And the fourth property of symmetric matrix is if A is symmetric, then Ka is also symmetric. I am saying that A is symmetric. If we multiply the given symmetric matrix with a scalar, where K is scalar, Ka is also symmetric. Ka is also symmetric. So these are the 4 points you should remember as a properties. You can check if you want solution for this, you want proof for this. I said that diagonal matrix is a symmetric matrix. Take a diagonal matrix, do its transpose and check, verify the elements, right? And next, let us discuss the next type of matrix, which is skew symmetric matrix, which is 12th type of matrix. I am erasing this 11th type. Skew symmetric matrix. Just one thing you observe here in the skew symmetric matrix, A transpose is equal to minus A. Then the matrix is said to be skew symmetric matrix. If A transpose is equal to A, we said that the given matrix is symmetric, right? Now I am writing about skew symmetric matrix. What is this skew symmetric matrix? You can see here A transpose is equal to minus A. This matrix is nothing but skew symmetric matrix. Okay, if I ask to write one example, I already told that the principal diagonal elements in symmetric matrix are always real numbers. But here the principal diagonal elements, okay, PDE, are zeros. PDE are zeros here. So let's begin an example. A is equal to, I told that PDE are zeros. 0, 0, 0. So let me write 3 cross 3 matrix. If I write 6 here, what is the position? The position is 1, 2. First row, second element. Write its replica 2, 1, but with a opposite sign. 6 means here you need to write minus 6. If I write minus 9 here, what is the position? The position is 1, 3. Its replica is 3, 1. You need to write opposite sign. Minus 9 means here it is plus 9. For plus no need to write. If I write 10 here, what is the position? 2, 3. Its opposite replica is 3, 2. Opposite sign minus 10. So this is the given matrix A. For this given matrix, let me check A transpose is nothing but minus A or not. So simply I will do A transpose, just interchanging the rows and columns. I'll take rows. The first row is 0, 6, minus 9 is the first row. I will write this as column. So the column becomes 0, 6, minus 9. I will take the second row, minus 6, 0, 10 as the second row as second column. I will take the third row, which is 9, minus 10, 0. Okay, 9 minus 10, 0 as third column. Now just what I will do, is I will take minus outside. I will take minus outside. What's happened? So write that if you take minus outside, what's going to happen? 0, 6, minus 9. Minus 6, 0, 10. 9, minus 10, and 0. Now you can check here. Your A transpose is exactly here, it is the value A but with a symbol minus. So A transpose is equal to minus A. Note down this. Very important point. For symmetric matrix, the principal diagonal elements are real numbers. For skew symmetric matrix, the principal diagonal elements are zeros. So remember these two. Okay, and now let's discuss the properties of skew symmetric matrix. In a skew symmetric matrix, all the elements in principal diagonal elements are zeros as the first property I told. Let's see the second property of skew symmetric matrix. Zero matrix will come under skew symmetric matrix. You can see all the principal diagonal elements are zeros. If A is skew symmetric, then A minus A transpose, A minus A transpose will also become skew symmetric matrix. If A is skew symmetric, then Ka, scalar, where K is scalar, Ka is also skew symmetric matrix. Okay, if A is skew symmetric, then these two things will happen. One is A minus A transpose will become skew symmetric. Second one is Ka will become skew symmetric matrix. If A is a square matrix, then let me erase this. A plus A transpose by 2 let me write the property. If A is square matrix, then A plus A transpose by 2 is symmetric, whereas A minus A transpose by 2 is skew symmetric. So this is symmetric and this one is skew symmetric. Every square matrix can be uniquely expressed as sum of both symmetric, this one A plus A transpose by 2, and a skew symmetric, which is A minus A transpose by 2. Right? So these are the properties of skew symmetric matrix. Here we got one term, that transpose, right? So let us discuss what is transpose. Just I told you in this example only, I explained you transpose is nothing but interchanging the rows and columns. But there are some properties of transpose. You need to learn those properties. So let me write here, we learned one thing, transpose of a matrix. So just swapping, interchanging rows with columns or columns with rows. Right. So for example, if I take A is equal to Aij, whose order is M cross N. Then what about A transpose, which is Aji, whose order is N cross M. Now here the properties are important. This is a mathematical notation. The properties are important. A transpose whole transpose, which is A. A transpose whole transpose is A. Second property, we have Ka whole transpose, which is K into A transpose, where K is a scalar element. And third property, we have A plus B, two matrices, whole transpose can be written as A transpose plus B transpose. And the fourth one, last one, AB whole transpose can be written as B transpose into A transpose. Some properties may comes for you in examination directly. Which of the following is true? In that manner, some properties may come. Right? So these are the properties of transpose of a matrix. Actually, why I discussed here transpose of a matrix is, I discussed about symmetric as a type number 11, skew symmetric as a type number 12. In that, a term involved, which is a term is involved here, which is transpose. Hence I discussed about transpose and its properties. Let's move on to the next type of matrix. So next type of matrix that we have is invaluatory matrix. The next type of matrix that we have is invaluatory matrix. What is invaluatory matrix? Invaluatory matrix, a matrix A is said to be invaluatory if A square is equal to I. So in the exam he will give a matrix. Check the given matrix below is options invaluatory or idempotent. Likewise he will give. So let's have one example. A is equal to 4 minus 1 15 minus 4. So the given matrix is invaluatory or not? Let's check. So let's check this. 4 minus 1 15 minus 4. Okay, just I written A square here. A is the given matrix, just I am doing multiplication A square. So just do its multiplication, rows, columns. 4 4 ja 16 minus 15. 4 into 4 16 minus 1 into 15 15. Next minus 4 minus of minus plus 4, just I am doing multiplication, and next 15 4 ja 60 minus 60 minus 15 plus 16. So what you will get here, 1 0 0 1, isn't it? So it is an identical matrix of order 2, right? Hence the given matrix is said to be invaluatory matrix. Okay, this is the another type of matrix that we have. Next we'll discuss the next type of matrix. The next type of matrix we have idempotent matrix. Idempotent. So what is meant by idempotent matrix? A matrix A is said to be idempotent if A square is equal to A. Then the matrix is called as idempotent matrix. For example, no need to write example. He will give the question. No need to frame the question. 4 minus 1 12 minus 3. The given matrix is idempotent or not? Let's check whether it is idempotent or not. So how to check the given matrix is idempotent or not? 4 minus 1 12 minus 3. Just do multiplication, A into A. What we will get? 4 4 ja 16. This is minus 12. Minus 4 plus 3. 48 minus 36 minus 12 plus 9. Just compute this. What you will get? 4 minus 1 12 minus 3. As it is like A. As you got A square is equal to A, hence the given matrix is said to be idempotent matrix. If A square is equal to I, the given matrix is said to be invaluatory. But here it is A square is equal to A, hence the given matrix is known as idempotent matrix. So note down this. Let's go to next matrix. Which is orthogonal matrix. Let me erase this. So the next type of matrix we have orthogonal matrix. What is orthogonal matrix? The matrix A is said to be orthogonal if A into A transpose is equal to I is equal to A transpose into A. That matrix is known as orthogonal matrix. So for example, before writing properties, let's have one example. If I write 1 0 0 0 0 1 0 1 0, you people please compute A into A transpose or A transpose into A. Then you will get the value as 1 0 0 0 1 0 0 0 1, which is nothing but identity matrix. Hence the given matrix is said to be orthogonal matrix. So what are the properties of orthogonal matrix? If I talk about the properties, A into A transpose is equal to I. Here I written, from this I taken. If I write A transpose, I want to send this A below. So what I get? I by A. That means A transpose is equal to, if A comes above, A inverse. This is very important property. If someone asks you to compute inverse of a orthogonal matrix, inverse means for orthogonal matrix it is a transpose. Just interchange the rows and columns. That's it. On the other hand, we have one more property. A into A transpose is equal to I. The basic thing I written. Now take determinant on both sides. Determinant on both sides. Det AB can be written as det A into det B. Okay, det AB can be written as det A into det B. That means here det A into det A transpose is equal to det I. If you compute the unit matrix or identity matrix, so determinant is product of principal diagonal elements, as it is like diagonal element, diagonal matrix, so which is 1. Determinant of A transpose is same as determinant of A, where I am going to discuss all these properties in the concept of determinants. So what we will get? Det A into det A is equal to 1. Det A into det A, which is det A whole square, is equal to 1. So det A is equal to plus or minus 1. So this is another property of orthogonal matrix. Please note down this. Note down this. Right. Let us discuss the next type of matrix. I hope you noted this. Now let us discuss the next type of matrix. So we completed orthogonal matrix. Next we have singular and non-singular matrices. So let me erase all this. So we'll discuss the next type of matrix, singular and non-singular matrix. So what is singular and what is non-singular matrix? A matrix A is said to be singular. Okay, a matrix A is said to be singular if determinant of A is equal to 0. Such matrix is called as singular matrix. Non-singular means determinant of A is not equal to 0. For example, let us take a basic thing. A is equal to 1, 2, 2, 1. If I ask det A, AD minus BC. Again in the determinants we will discuss how to compute det A for 2 cross 2 and how to compute det A for 3 cross 3. So 2 minus 2. It is 0. This is singular matrix. For singular matrix, inverse does not exist. For singular matrix, inverse does not exist. Non-singular means that A is not equal to 0. If I write A is equal to 1, 2, 3, 4. If I ask that A, AD minus BC, 4 minus 6, which is minus 2, which is not equal to 0. So this is non-singular matrix. Please note down this. Please note down this. Okay. Now, these all are the types of matrices that we discussed. సో ఈరోజు క్లాస్లో నేను మ్యాట్రిక్స్ డెఫినేషన్ చెప్పాను. నియర్లీ చాలా మ్యాట్రిక్స్ విత్ ప్రాపర్టీస్తో పాటు డిస్కస్ చేయడం జరిగింది. నెక్స్ట్ క్లాస్లో మీకు చాలా చాలా ఇంపార్టెంట్ క్వశ్చన్స్ కూడా దాని మీదే వస్తున్నాయి. డిటర్మినెంట్, అడ్జాయింట్, ఇన్వర్స్, సిస్టమ్ ఆఫ్ లీనియర్ ఈక్వేషన్స్, ఈ 4 టాపిక్స్ మీద డిస్కస్ చేయబోతున్నాను. సో నెక్స్ట్ క్లాస్లో వీఆర్ గోయింగ్ టు స్టడీ అబౌట్ దిస్ 4 టాపిక్స్. వాట్ ఆర్ దోస్ టాపిక్స్? డిటర్మినెంట్స్, adjoint, inverse, system of linear equations. వీటి మీద మీకు క్వశ్చన్స్ ఎక్కువగా వస్తాయి. ఈరోజు క్లాస్లో చాలా బేసిక్స్ నుంచి టైప్స్ ఆఫ్ మ్యాట్రిసెస్ ప్రతి ఒక్కటి నేర్చుకుందాం. సో నా సిన్సియర్ రిక్వెస్ట్ ఏంటంటే ప్రతి ఒక్క స్టూడెంట్ నెక్స్ట్ క్లాసెస్ నుంచి వచ్చేటప్పుడు కొద్దిగా పేషెన్స్గా ఫస్ట్ నుంచి లాస్ట్ వరకు లైవ్లో ఉండండి. ఏవైతే కొన్ని ట్రయల్ క్లాసెస్ ఫ్రీగా లైవ్ క్లాసెస్ ఇస్తున్నామో ఈ క్లాసెస్కి మీ ఫ్రెండ్స్ ఏ కాలేజెస్లో అయినా ఉండనివ్వండి, ఏ బ్రాంచెస్ అయినా కానివ్వండి, మ్యాథ్స్ కామన్ ఫర్ ఆల్ కదా, వాళ్ళకి కూడా ఈ లింక్ షేర్ చేయండి. వాళ్ళని కూడా పట్టుకొని రండి ప్రతి ఒక్కళ్ళు. ఓకే, నెక్స్ట్ క్లాస్లో నేను మీ అందరికీ ఫర్దర్ కంటిన్యూషన్ ఆఫ్ దిస్ మ్యాట్రిసెస్ చెప్తాను. అండ్ ఈ డౌట్స్లో కూడా నాకు చాలామంది సార్ ట్రిగ్నామెట్రీ చెప్పండి, ఇంటిగ్రేషన్స్ చెప్పండి, డిఫరెన్షియేషన్స్ చెప్పండి, ఇట్లా కొన్ని స్టార్టింగ్లో పెట్టిండ్రు. ఆ టాపిక్స్ కూడా నేను మీకు డిస్కస్ చేస్తాను. ఆల్ ద థింగ్ దట్ ఐ నీడ్ ఈస్ యూ షుడ్ బీ స్టే ఇన్ లైవ్ కాన్స్టెంట్లీ. ఏదో స్టార్టింగ్ వచ్చినాము మధ్యలో వెళ్ళిపోతే ఏం అర్థం కాదు. ఫస్ట్ నుంచి చూస్తే మాత్రమే నేను చెప్పే ప్రతి థింగ్ చాలా నీట్గా అర్థమవుతుంది. ఒక యావరేజ్ స్టూడెంట్కి కూడా, నార్మల్ స్టూడెంట్కి కూడా అర్థమయ్యే లెవెల్లో నేను టీచ్ చేస్తాను. చాలా బేసిక్స్ నుంచి టీచ్ చేస్తాను. మంచి మంచి షార్ట్ కట్స్ కూడా, ప్రాబ్లమ్స్ డిస్కస్ చేస్తున్నప్పుడు షార్ట్ కట్స్ కూడా చాలా బాగా వస్తాయి. ఆల్ ద థింగ్ యూ నీడ్ ఈజ్ పేషెన్స్. పేషెన్స్గా ఉండండి. అండ్ సెకండ్ థింగ్, మీకు ఏ డౌట్స్ వచ్చినా నాకు వాట్సాప్లో మెసేజ్ చేస్తున్నారు, నేను రిప్లై ఇస్తాను. వితిన్ 24 అవర్స్లో రిప్లై ఎక్స్పెక్ట్ చేయండి. ఓకే, ఫర్దర్ నెక్స్ట్ క్లాస్లో మనం కంటిన్యూ చేద్దాం. అండ్ నెక్స్ట్ క్లాస్లో కూడా సేమ్ స్ట్రెంత్ ఇప్పుడు ఎలాగైతే వచ్చారో ఇంకా ఎక్స్ట్రా స్టూడెంట్స్ రావాలి. రైట్, థ్యాంక్ యూ ఫర్ వాచింగ్ టుడేస్ క్లాస్. అండ్ ఫైనల్లీ ఐ వాంట్ టు టెల్, టెక్నోగేట్ ఎడ్యుకేషన్ అనే యూట్యూబ్ ఛానల్ మీరు ఏదైతే చూస్తున్నారో, టెక్నోగేట్ ఎడ్యుకేషన్ అనే యూట్యూబ్ ఛానల్ ఏదైతే ఉందో, ఈ యూట్యూబ్ ఛానల్ని ప్రతి ఒక్కళ్ళు, ఓకే, టెక్నోగేట్ యూట్యూబ్ ఛానల్ని ప్రతి ఒక్కళ్ళు లైక్ చేయండి, షేర్ చేయండి అండ్ సబ్స్క్రైబ్ చేసుకోండి. ఫైనల్గా బెల్ ఐకాన్ కూడా ఉంటుంది, మీకు నోటిఫికేషన్స్ రావాలి అంటే ఆ బెల్ ఐకాన్ మీద కూడా క్లిక్ చేయండి. మీ అందరి బాధ్యత, టెక్నోగేట్ ఫ్యామిలీ మెంబర్స్ అయిన మీ అందరి బాధ్యత మీ ఫ్రెండ్స్ని కూడా తీసుకొచ్చి ఈ ఛానల్లో పడేయడం. జస్ట్ ఒక సబ్స్క్రైబ్ అనే బటన్ నొక్కితే చాలా అప్డేట్స్ వస్తాయి కదా, యూస్ఫుల్ అప్డేట్స్. ఎన్నో మెసేజెస్ ఫార్వర్డ్ చేస్తూ ఉంటాం. దీన్ని కూడా కొద్దిగా సీరియస్గా తీసుకొని ప్రతి ఒక్కళ్ళు ఈ ఛానల్ ఏదైతే ఉందో ఆ ఛానల్ని మీరు షేర్ చేయండి. ఈ ఛానల్ యొక్క వీడియో కూడా నేను ప్లే చేస్తున్నాను, ఒక్కసారి చూడండి. టెక్నోగేట్ ఎడ్యుకేషన్ ఛానల్ నేమ్ టెక్నోగేట్ ఎడ్యుకేషన్, గుర్తుంచుకోండి. యూట్యూబ్ లింక్స్ కూడా మీ అందరికి వచ్చినాయి, ఆ లింక్స్ మీ ఫ్రెండ్స్కి కూడా ఫార్వర్డ్ చేయండి. ఇదిగోండి, ఇక్కడ ఛానల్ డిస్ప్లే అవుతుంది, టెక్నోగేట్ ఎడ్యుకేషన్. ఈ ఛానల్లో మీకు వీడియోస్ కూడా వస్తాయి, నేను చెప్పిన లైవ్స్ కూడా ఉంటాయి, ప్రతి ఒక్క థింగ్ మీకు అవైలబుల్గా ఉంటుంది. ఓకేనా? సో నెక్స్ట్ లైవ్ ఏదైతే ఉందో, నెక్స్ట్ లైవ్లో చాలా వరకు మీకు ఇంకా అప్డేటెడ్ టాపిక్స్ అండ్ కొన్ని షార్ట్ ట్రిక్స్ ప్రతి ఒక్కటి అప్డేట్ చేస్తాను. నెక్స్ట్ క్లాస్లో మ్యాట్రిసెస్ అయిపోతుంది, ఆ నెక్స్ట్ క్లాస్లో పార్షియల్ ఫ్రాక్షన్స్ స్టార్ట్ చేద్దాం. సిలబస్ వైజ్గా నేను మీకు కొన్ని వింగ్స్ ఇద్దామనే ఉద్దేశంతో ఎగ్జామినేషన్కి యూజ్ అయ్యేటట్టు నేను ఈ మాడ్యూల్ స్టార్ట్ చేశాను. లాస్ట్ వరకు ప్రతి ఒక్కళ్ళు లైవ్లో ఉంటే దట్ షోస్ యు ఆర్ వెరీ సీరియస్ స్టూడెంట్స్. దీంతోపాటు ఇవి ఫ్రీ క్లాసెస్ వస్తున్నాయి కాబట్టి మీ ఫ్రెండ్స్కి కూడా మీరు ఇది షేర్ చేయండి. ఈ ఛానల్ని ప్రతి ఒక్క స్టూడెంట్ సబ్స్క్రైబ్ చేపించండి. టెక్నోగేట్ ఎడ్యుకేషన్. సీ యూ ఆల్ టుమారో. థ్యాంక్ యూ.